fundamental concepts of the security models. The main goal of the security program is to always maintain the confidentiality, integrity, and availability in a good shape. Therefore, for the security architecture, it's a very difficult task to do this. The main role of the security architecture is to translate whatever the business requirements are into a solution in order to provide very good security for the key assets that are being protected. Because the security policy outlines only the goals of the security plan. Therefore, it is really necessary to have a model or a framework that gives a policy a shape or a form in order to provide. Now we're going to talk about some security models that were developed in the past in order to enforce security policies. These security policies will help us understand the complex security mechanisms in the information systems, and at the same time it's going to show how difficult this is to maintain. Now we're going to talk about some security model types. Like I mentioned before, the security model brings or takes whatever is in the security policy to one particular way to implement it. These security model types are state machine model, multi-level lattice models, matrix-based models, non-interference model, and information flow models. The state machine is based on objects and attributes, while on the lattice model, we define upper and lower bounds. In the non-interference model, we define some barriers or bounds in order to prevent data leakage. And information flow models, where data flow between objects and security levels. In order to keep talking about the security models, we need to talk about subjects, objects, and access. So I know we talked about the subjects and objects in the past, but I want to talk about this again because it's very important for our purpose about the security model. The subjects are entities which have actions, and these actions are over the object. These objects could be users, processes, or any process or instruction within the machine. So because they have actions, so they're not static. And the subjects work over the objects. And objects are resources on any place. So this could be files, documents, records, or anything that is passive on the system. And the relationship between objects and objects is that objects which are active work over the objects which are resources which are inactive. There must be a way in order to control how the subjects and objects interact to each other, because we want to avoid unauthorized access to resources or objects, because not everyone in the organization will be able to access the different resources, right? Therefore, we need to control how the subjects interact with the resources. The state machine model. This is an abstract model that tries to describe a system that is always secure, no matter in what its state is. This is based on the computer science definition of the finite state machine, or FSM. The main objective of this model is to provide a model about that information has to be always secure, regardless of the state where this is. So if you have a computer system that is changing a state from state, for example, you're just having your computer in a booting section on the operating system, the information has to be always secure. And while you're operating your computer and you're just running everything, the information has to be secure in that state. If you're having some failure or computer failure, you have to have this computer in the secure state. This is the main objective or main goal of this state machine model, because it tries to show or describe that regardless of the state, the information has to be always secure. The state machine model depends on security levels, classification, and clearances. And there are two types, or two different sections of this state machine model, which are a state machine and multiple state machine. Or on a single state machine or policy driven, all the processes and everything works on a single security level. So there's no up and lower security levels. So there's no way to separate classifications because everything operates on the same level. And all the users must have full clearance and formal approval in order to access the information. On the multiple state machine, this is more flexible but less secure. So processes or data, they can live on different security levels without the risk of compromising the security. And data can be classified because there are different levels of security. And not all the users require full clearance. This is the reason why it is more flexible, I can see it, but it's less secure. Lattice-based access control. This is a control that allows security controls for complex environments. On this model, for every subject and object, there are some defined upper and lower access limits or boundaries. Therefore, on this model, there are defined some subjects and objects where subjects have clearances and objects have levels of security. Subjects have a least upper bound and greatest lower bound, which restrict the access of the information. This is often represented in a matrix, which defines which objects are permitted to access on the objects. For example, in the matrix, we can have some security levels like private, sensitive, and public. Therefore, if the subject or the entity or the active entity has clearance to only sensitive level of security, the subject is going to be only able to access this information. This model is often used for confidentiality and integrity, in this case for Bella Padula and integrity for BIBA. Non-interference model. This security model ensures that data at different security domains remain separate from another. Therefore, in this case, subjects and objects are assigned to different domains, and they are not allowed to access one domain to another in order to avoid interference with the other domain. So for example, if you're having security levels, one subject and one security level cannot talk to other security level because they don't want to interfere to each other. This is the reason why this is called no interference. With this, we avoid some influence in the information or decisions made on the other security domains. This security model also works with covered channels, and the covered channels are policy violating communication that is not seen or hidden from the owners of the user. Therefore, this violates the security policy. Addressing this, we avoid communication leakage and influencing other information. The information flow model. This is a model based on the flow of information. This model focuses on how information is allowed or not allowed between individual objects. The information flow module are used to determine if information is being protected through a given process. That being said, this information flow model describes how the information has to flow in order to be secure. In addition to the previous security models, we have the access control matrix, which is a model which defines access permissions between specific subjects and objects in a table. This matrix represents the relationship between the subject and object and what level of access you have or the subject has over the subject. For instance, if you have an object, a resource, so this is going to specify if you have read, write, or execute rights on this object. So this is how basically this works.